Okay. Yeah, thank you very much for a very good introduction, and good morning, everyone. Could see a lot of good friends here and a lot of audiences from different trades of life. And today this topic is about digitization throughout the building of life cycle, from design to O&M. Okay, so here is the agenda. So in the next 25 minutes, first I will introduce our company, and then we talk about the life cycle of the buildings. And then talk about some digitization tools like BIM and also some cloud-based and IoT-enabled analytics, and then draw the conclusion. Before I start, I would like to introduce myself first. Actually, I came from CLP. I could see a lot of good friends here, no matter it's on-site or online. So you can see I left CLP around 10 years ago, and I spent around 11 years at CLP. I joined CLP at year 2000, and I joined as a trainee and power systems and maths, and then a commercial group. Here you could see the picture. Yeah, it's exactly 10 years ago in March. And it was taken in a BPBS, Black Point Power Station, when I was in a commercial group. A lot of good friends, a lot of good memories. So can't imagine. And right now, I came back to CLP in another role, actually, to speak. So it's my honor to speak at CLP in this time. A lot of good friends actually asked me before this symposium, they asked me what I did over the past 10 years. So I would like to spend around 30 minutes, 30 seconds, so 30 minutes on this topic, but 30 seconds on what I did over the past 10 years, so to show you, I was not captured by UFO. And 10 years ago, I left CLP for my MBA at London Business School. It's a 2-year program, and after I graduate, I joined Poulton & Partners in London. If you're from commercial group or LNG projects, you know Poulton & Partners, very specialized in LNG and gas. And after I quit Poulton & Partners, what I did, I went to Harvard for my MBA in Master in Public Administration. It's a 1-year program, and then I came back to Hong Kong to join the Lantau Group. A lot of people here know White Thomas, right? Yeah, so here's the managing partner of Lantau Group. It's a 1.5 years, and afterwards I joined Aviation and then Schneider Electric. So that's my history over the past 10 years. You can see my career is like an electron, and then molecule, LNG and gas, and then come back to electron. But these two electrons are very different. The first electron, when I was at CLP, is like energy, is an electron as an energy. And then afterwards, right now I'm a Schneider Electric, it's electron as information. So these are two different things. And every change in my life is like a career switching to me. So it's a very simple introduction about myself. Now, introduce Schneider. Need to talk about my company, because a lot of people will ask, okay, are you a German company? No, we are a French company. First, to be very clear, talk about our revenue first. We make 25 billion euros in the past 1 year. The largest market of us, what is it? Is in the Asia Pacific now. Although we are a French company, although we are a European company, but the lion's share of our revenue came from Asia Pacific, and it's also the growing market. How many people we have? It's around 130,000 people, over 100 countries around the world. How about the revenue breakdown? We have 2 major business units. First is energy management, accounts for around 3/4 of our revenue. Another 1/4 is from our industrial automation. So, and then here is the history, 4 steps. Actually, it's in line with the mega trends of the world over the past nearly 200 years. First, 185 years ago, we started in France, in Paris, as a steel company, steel manufacturer. Why? Because it's the industrial revolution in the British Empire. Okay, a lot of people at that time need steel. When we enter the 20th century, because of the invention of electricity, then we make our first transformation from a steel company to an electricity equipment supplier. But around 20 years ago, because of the invention of our computer or the very rapid developments of the IT world, we made another switching. It's called energy management and automation. Yeah, we tap into the computing power. And over the past 10 years, then a lot of people talk about Industry 4.0. So we make the 4th transformation. Okay, we talk about digital transformation. Throughout the past 185 years, we made a lot of acquisitions. So that's the growth model of Schneider Electric, and it's also studied in Harvard Business School. And here is the last slide about the introduction about our company. We place a lot of emphasis on environmental protection, and also sustainability. For example, half of our revenue draw from digital and energy-related business. And we also made a very huge, ambitious sustainability commitment. By 2025, it means 4 years later, we need to be carbon neutral. It means that we need to reduce 800 million tons of carbon in the next 4 years. And by the end of this decade, 2030, so we will be net zero, okay? So this will be our very ambitious sustainability commitments. That's the company introduction, and I hope you enjoy this. And now, we come to the core of this presentation. It's about the buildings. Here is the very high-level helicopter view about my presentation, buildings of the future. So what I talk about is, first, I will talk about the building life cycle, how many different stages, and what are the key stakeholders in the buildings. And the second one is the lifespan of a building, around 30 years, but the performance will decrease. It means that we will have more opportunities for value engineering. And then how we can do so. Digitization is a very good way. How we can capitalize on those technologies like BIM, IoT, cloud computing to do this. This will be my presentation. Now, very brief introduction about the life cycle of the building. As you can see, the first few years on design and then construction. But you can see, if I talk about lifespan of a building is 30 years, then 25 years will be more on O&M. It also means that O&M will be more correlated to our people. And also, the operating cost, OPEX, of O&M will be much larger. And later, I will give you a figure, okay? Larger than the design and construction. If we need to do value engineering, if we need to improve the performance, then the O&M part, we really need to do so, okay? Yeah, here we show you a different stakeholder, as I said before. The first one is the consultants. They are more engaged in the early 2 stages, like design and construction of a building. And the second one will be contractors, more on the construction. And the third will be the owner or facility managers, will be over the whole O&M stage. You can see what are the key features, not many overlaps, for example. Okay, the first one you can see, okay? So communication may be a problem. And the second thing is, very classical economic problem. It's called principal-agent problem. It means that the agents will act at the best interest of themselves rather than the principal. Of course, I believe all the consultants and contractors are very professional. But at the same time, we also need to take care of this because it's inherent in the human nature. That's the problem that we need to solve. And what's the problem? As you can see from the left-hand side, this graph, you can see the performance will decrease over time across different stages of the life cycle. For example, the design one, of course, is flat. Everything is perfect on the paper. When it enters construction, because of the site defects, site constraints, then the performance will decrease. Right after it enters the O&M stage, then the performance will decrease quite rapidly. Yeah. So what are the problems? For example, your lack of the project management, your lack of communication among all the key stakeholders, and how can we improve the performance? What's the target of us? It will be on the right-hand side, as we can see. That's our target, our ambition is try to maintain the performance of the building, okay, uniformly over the entire life cycle. And what can we do so is digital technology. For example, we can use it to do the energy saving, to maintain the reliability, to maintain our comfort, to do the retro commissioning. A lot of things we can do to capitalize on digital technologies to help us. Now, if I compare these 2 graphs, okay, the first one minus the second one, you can see will be the right-hand side, this graph, right? So this will be the value we can add. We call this value engineering. As you can see, the value will increase over time. And how can we do so? 2 things we can do in different stages of life, okay, is the first one, on the construction side, we can use BIM. A lot of people will talk about BIM. How can we use BIM to enhance the value of our buildings? I will explain later. And the second will be the O&M stage. You can see huge potential of value engineering, a lot of value we can do. So we can use the IoT-enabled and cloud-based analytics for you to do so. So, BIM, let's talk about BIM. Now, give you some statistics before. McKinsey in 2015, they said that, okay, we surveyed 22 industries. One of them is the building industry. What's the ranking? It's 21st. Not the first, 21st out of 22 industries. It means that we have a lot of improvement to do in the digitization of the building industry. And the second thing, how about operation efficiency? Just 40%. Okay, a lot of inefficient in the building industries during the design stage. And also the third one, how about the data efficiency? 96% of data is waste. We generate a lot of data in the construction and design stage and operation stage, but most of the data will go unused. So a lot of inefficiency. So we need to tap into those data to help us to do the value engineering. Now, the first one is BIM. BIM, a lot of people will say that, yeah, AutoCAD. Exactly. When I was at university time, like this 20-something years ago, we do the AutoCAD. It's the origin of the BIM, 2D drawing, and then 3D drawing. A lot of animations, you can shake, you can rotate, right? But it's not enough. So in the past 10 years, you can see a lot of improvement in the BIM technologies. For example, it will be equipped with more and more functions and other tools to help you to do the forecast, projection, okay, a lot of different kinds of simulations. But the top stage is you need to have a very integrated platform to give you the 5D, not just 3D, and also to give you the single platform of truth that you can have. And that's the value of the BIM. As I said before, different stakeholders through the design and construction stages, you will rely on different sources of truth for you to proceed the project management. That's lack of communication. That's why you need this. Okay. Oh, sorry, a little out of control. Okay, yeah. No problem at all. So 5D, what is 5D? 3D, we know that, right? It's the space. Okay, 5D, it means that it's 4D is the time, and then 5D is the cost. So we add 2 more dimensions. Of course, some people will say, okay, we have 10D or even more. So it depends on how many dimensions or matrices you need to add to measure the performance. So with 5D, we can do a lot of different things for you to do the better project management, simulation, projection, or optimization, whatever you can do. Second thing is a lot of stakeholders. Okay. Yeah. A little bit out of control, but no worries, I can control this. Single source of truth, a lot of different stakeholders on the same platform, BIM platform. So there will be no confusion, no misunderstanding. Everyone is on the same page. And that's the thing that BIM can add value to you. Oh, every time I click one, it will jump, but no worries. Okay, yeah. And this is the hierarchy, as you can see, about the data. The lowest layer is the data. It means nothing, although data is the king, but if you don't draw any insight from the data, it's useless. So how we can refine the data, 4 levels, from data to information, with some meaning behind, and then to the knowledge, okay? With more meaning, you can know the know-how. And the highest layer is the wisdom. Just like human beings, we can think strategically. We can make decisions, and that's the wisdom. As you can see, we need AI on the wisdom part. We've already very well developed knowledge, information, and data. The next stage is to incorporate the AI into the model and know why. As you can see, this also aligns with the civilization of human beings. And how we can do so? On top of AI, we can also add a lot of smart sensors, okay, to measure no matter what, like the space, like the temperature, humidity, a lot of environmental indicators you can measure, no matter it's about the human, the machine, the materials, a lot of different things you can just measure, and it's automatic input to eliminate any human errors. So you can input it in real time. You don't really need to tolerate some time for the human input, or it's also prone to errors. And then you can add with the visualization technologies like the IR, VR to help the stakeholders better visualize the site conditions, no matter it's on the resource or materials or plant or site, anything. Okay, you can also do this with the VR technologies. It's very, very intelligent. And the last thing, you can also add with the digital twin. So what is a digital twin? It's just like a digital copy of a physical object. So a lot of people will rely on digital twins to do these simulations. Okay? If I have a piece of asset, I have lots of data. I know its performance. If I want to change, I want to do some change or to add something. What will happen next? So that's what the digital twin can help you. There are lots of benefits. For example, I just mentioned a few. It can shorten the site construction time, your cost, and also increase the quality with the use of the digital twin. So based on the BIM, as you can see, a lot of technologies can add value or based on the BIM to provide more benefits to our site management during the construction stage. And then next, I will talk about the O&M stage. Now, as you can see, I mentioned this before. Throughout the life cycle, what will be the life cycle cost of a building? If I divide it into the design and construction and also O&M, you can see it's the first hill on the left-hand side. It's around 20 to 40%. What it means, 20 to 40% of the life cycle cost is incurred during the design and construction stage, but 60 to 80% will be incurred on the O&M stage. As you can see, a lot of cost. It also means that a lot of value or benefit we can get from the O&M stage. That's the meaning of this graph. And to give you some more figures, it's like a wild animal, sorry. Okay, yeah, the pointer is so interesting. Some more statistics, not just the cost. How about sustainability? Buildings, they emit 40% of our carbon emissions, so quite a lot. And then how about resiliency? You know what? Every year we have more than 300 disasters over the world. It also means that every day we have one disaster, no matter it's typhoon, earthquake, volcano, eruption, or other things, okay, over the world. Next, efficiency. 30% of our energy is waste in buildings, okay? For example, in Chile, it's the most energy-consuming one. And next, people centricity. You know what? We spend 90% of our lifetime in buildings. It also means that we are highly correlated to the building's performance. If the buildings are good, to provide you very comfortable environments and well-beings, of course, it will be very good for you to perform higher. Okay? No matter it's for you to live, to work, to play, to rest. Okay? So we are highly correlated to the indoor performance of the buildings. Okay. Now, I will call these four matrices the key values in the buildings of the future. Sustainable. Our buildings must be sustainable, use less energy, and emit less carbon. The second thing is resilience. Resilience can be physical and also can be digital. Physical, I know you already know, okay, back in around 10,000 years ago. So buildings or our shelters will provide us this kind of physical resiliency against the wild animals, against the natural disasters. And then right now we are also talking about cybersecurity. It's another space, okay? And the third one, highly efficient. Of course, energy efficiency. But the second thing is, we also need to remotely control and manage our buildings. So we don't really need to get back to the sites to manage our buildings, especially during the COVID time. We've already come to the new normal. Okay? We have to work remotely. So WFH, work from home, whatever, work from hotel, work from hospital, whatever. Okay? You can manage or do your work remotely. And that's the future buildings need to provide you. The last thing, we will call this is a very essential element in the buildings of the future, people-centric. We need buildings, first, to provide us very comfortable environment. And the second thing is to help you think and make strategic decisions. And it will be more human-like. It will be like your friend, like your soul. It's not just a physical asset. And that will be the buildings of the future. People right now call it smart buildings, but in our Schneider language, we call it buildings of the future. It's just like it has a soul. It knows you well. Okay? Now, what are the four, you can see the four key values, but it's underpinned by one thing. It's the mega trend of the world, it's the digitization. So I would say digital will disrupt efficiency and sustainability of the world, you can see quite some figures on the right-hand side is about IoT, about big data, about AI. So the increase not just double, okay, but we can triple or 5 times or 6 times. And here is the eco-structure and that our company will provide you. Actually, if you study IT or computer engineering, you know this kind of infrastructure is like we divide the IoT architecture into 3 layers. In plain language, the bottom one is called hardware. Just like you know about Schneider Electric, we have transformers, switchgears, and bus bars. Okay, those are the hardwares. And the second layer will be the software. BMS and EMS. So, okay, and this will be our control. And the third layer will be our analytics. Okay, it will help you think. It will analyze the data. Okay, so that's the way that we go. And we have 4 major advisors to help you to do or add value to you in different matrices. For example, our building advisors will do better management for you as an advisor to monitor the critical power assets like the equipment, like the transformers, switchgears, bus bars, okay, which are very critical to the health of power systems. And then power advisor to monitor the power qualities like the voltages and harmonics. And second, and the last one is the workplace advisor about the well-beings, about the occupants, of people flow and things like this. And last thing I would like to say is we talk about the Internet of Things. I will try to step up. I would say that's the Internet of everything in the future, not just the Internet of Things. So IoT and cloud will be the bedrock. Like it will underpin VR, virtual reality, and then digital twin, as I explained before, and blockchain to enable peer-to-peer energy trading and other commodities. AI help you think, and then automations, take actions, robotics. So it will be the future. If I can say the future, the buildings or any assets will be global. Okay, you can monitor, you can work remotely. And second thing, it will be more agile. It's real-time data. You can make the decision quickly. And smart and auto, it adds a lot of value to our human beings, and it's people-centric, and that's the thing, that the buildings will help you. So I will call this technologies for the access everything. If I can also call it further, it's global, it's everywhere. Agile, every moment, it's real time. And smart and auto is for everyone. So we have everything, everywhere, every moment, and for everyone. So it will be our future, and that's the power of Internet of Everything. I know this time's up. It's just a conclusion that, so in the future, our value should offer 4 big values: sustainable, resilient, hyper-efficient, and people-centric, and a lot of value we can add during the design, construction, and O&M stage. And the future will be digitization and innovation. So, and I know it's time's up, but I just want to say the last sentence is, okay, we are talking about the Internet of Things, but in the future, it will be the Internet of Everything, and it will be our future. Thank you very much.
Thank you, Kelvin, for the comprehensive sharing with us. Due to time constraint, we may have only time for 1 question, and we have received a few questions, and we picked the question that we would like to ask Kelvin. How does a company go about estimating the ROI for digitalization?
Okay, a lot of people, customers will ask us, how can we measure the ROI? I think there will be 3 stages, if I can divide it in here, try to put it in a very structured manner. The first thing is define your motivation, your ambition, your goal. What you want to do is you want to save your energy. You want to enhance the reliability, or you want to enhance the comfortability. IQ, things like this. Define your goal. And the second thing is define the matrices. For example, energy saving. Okay, how many kilowatt hours you want to save? Reliability, the reduction in downtime. So you will have a very clear matrices. And the third thing, it will be how we can do so. What technologies, okay, IoT, cloud, or other things can help you to do this kind of energy management. And then we will, as a Schneider Electric, we will say we have a customer success team, very professional, to help you to do so. We have reference cases all around the world, overseas, so we will have a lot of knowledge and data to help you to do this kind of ROI estimation and measurement.
Thank you so much, Kelvin.